I'm Thomas Hatsios, German America pilot flying the Boeing 787-900Z aircraft. In tonight's flight, we're going to be flying Switzerland, Germany, and then coming back to the Zurich International Airport for an ILS localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 Microsoft Flight Simulator X. I'm going to start showing you cockpit instruments, the displays and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel. We have also the altitude indicator with the artificial horizon, the pitch ladder decrease and the bank angle decrease, the vertical rate of climb descent of the aircraft intense has been permanent, all the steepness of the trigonometric angles increase and climb descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease. We have the ILS localizer, the instrument landing system of the runways, threshold antennas that transmit the radio frequency we receive from the onboard antennas of the aircraft, and so we can align the aircraft with the ILS localizer for takeoff and for landing. So we have the ILS localizer for the horizontal localizer and the vertical glide slope, the angle of approach. So we have a unique radio frequency. We have to tune each time we take off and land from a different airport and runway heading, magnetic North Pole heading. So I'm gonna show you how to use it. We have also the ILS localizer crossbars for manual guidance of the aircraft and the flight director crossbars for manual guidance of the aircraft. We have the autopilot crossbars for automatic guidance of the aircraft. The angle of attack of the aircraft as it flies in the flight mode and steer with the autopilot and the autothrottle. Later, a vertical navigation mode. We have also the HSI, the horizontal situation indicator, with the magnetic heading and track that displays also the flight plan, the integrated display of the flight plan we have created. So I'm gonna use the flight management computer here. I'm gonna create a flight plan later. I'm gonna input all the data of the aircraft for this flight. Is gonna be used also from the autopilot flight director system panel. When we connect the autopilot flight director system panel, is gonna follow the flight plan I'm gonna create here in the flight management computer. So you will see later how I'm gonna use this flight management computer input from the keyboard and use the mouse pad also. The data we need is going to be displayed here in the navigation display, the horizontal and vertical profile. Also in the HSI you're going to see the flight plan we're going to create. So you can see the primary flight display here with the flight mode annunciator, the altitude indicator, the airspeed, barometric altitude above the sea level, and the vertical rate of climb and descent. So in the navigation display also we can see the magnetic heading and track, the GPS position of the aircraft, the magnetic North Pole and the geographic North Pole magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the terrain around you in a 360 degree, 180 degree view. Also you can see in front of you and below you the terrain when you fly in the vertical profile. So you'll see the terrain displayed with a red, green, yellow and amber color depending of the altitude difference with the aircraft as you fly, and the terrain in front of you, below you, also the distance from your aircraft. We can see also when we are in the ground, we have also the sea, the lakes and the rivers with blue. We have the terrain map that displays also the airports, where the airports are located, the distance from our aircraft when we fly, how many nautical miles we have to fly to an airport. Also we can see the runways we use for takeoff when we select it from the flight management computer for takeoff and for landing. You can see the runway length and magnetic North Pole heading. Also we can see the runways and the taxiways and the airport map. I will show you later. We can see also the navigation aids, the nav aids, which are the workstations, ADFs and DBs. Also the waypoints which are horizontal, vertical navigation fields and altitude and airspeed constraints. I'm gonna show you the waypoints, how we're gonna make a flight plan over here using the flight management computer. You're gonna see the waypoints one by one over here are gonna be connected with a purple or magenta line. Also you're gonna see We have the other aircraft that fly around our own aircraft displayed with a diamond shape. We can see other aircraft up to 14 nautical miles or 72 kilometers away from our aircraft in a 360 degrees view from the transponder. There is the ADSB an ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller receives from other aircraft can make calculations from the radio frequency difference. You can calculate the other aircraft distance up to 40 nautical miles or 72 kilometers. Also, the altitude difference from our aircraft and heading with our aircraft, the bearing. Also, we can calculate how many hundreds and thousands feet are above or below our aircraft, the altitude difference. Also, whether the other aircraft climb or descend with respect to our aircraft, and also I can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TICA system, the traffic collision advisory system. If we have an incoming collision in the air, we'll make an avoidance maneuver. So you can see the other aircraft displayed with the diamond, and the altitude difference displayed next to the diamond, and an arrow up or arrow down symbol where they climb or descend. We have also the, so you can see also we have, so this is for the navigation display. We have also the engines indications, the flight management computer, the autopilot flight director system panel, the flight controls of the aircraft. So I will show you the side stick that I use here to control the flight controls and the engines function. Also the mouse pad I use for the flight management computer and for the autopilot and the keyboard. I need to input the data here. Also the overhead panel, you're gonna see all the systems. We're gonna make an engine start demonstration of the airplane before we go into flight. So you will see everything we need to know. So you can see here we have the aircraft, the side stick of the Airbus, the Logitech Extreme 3D I can use for the Boeing for climb and descent using the yoke. Also we can make turns to the right using side stick left and right, or to the left, ailerons and spoilers. Also the rudder pedals which are used for the vertical tail rudder and also for the nose wheel steering of the aircraft in the ground. It's automatic, we don't need to do anything. We'll change overs between the rudder, the vertical rudder and the nose wheel steering. Also we have the toe bricks in the top surface of the rudder pedals. So the flight controls, I will show you how to use them. Also the engines, the thrust levers here, so we can actuate the engine thrust produced when we adjust the engine position, the thrust levers position over here. So you can see how many degrees you have your thrust levers. You can see the N1 that is requested here, which is a low speed starter sub low pressure compressor tube and the turbofan engine. You can see we're not configured for takeoff yet. We have the takeoff limit from the FAREX. The FAREX are the full authority digital electronic control computers, one installed per engine gearbox, dual channel redundancy, one channel fails, the other takes over, controls, monitors and displays all the engine data you see here. So we have the exhaust gas temperature, also the N2, which is the high-speed starter sub high pressure compressor tube and the turbofan turbocharged engine. The fuel flow per engine per hour in thousands of kilograms or thousands of pounds per engine, oil pressure, oil temperature, oil quantity and the vibration of the N2 states of the engine. Also you can see the cabin pressurization here when we fly. As we climb higher or lower, we have to pressurize the cabin, also automatic. We use the manual, we have to open or close the outflow valves. You will see the outflow valves position here to pressurize or depressurize the aircraft cabin. You can see the cabin altitude, the differential pressure, it will go 7.8 psi when we fly. At 45,000 feet or 43,000 feet maximum altitude, the cabin altitude should be approximately 6, 7 or 8,000 feet with a differential pressure of 7.8 psi. Also the landing altitude we need for the pressurization of the aircraft when we land. So you can see here the primary flight display. Also we have the airspeed indicated, the barometric altitude above sea level, The barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft contains 100,000 feet per minute, so we can climb. You will see 500, 1000, 1500, 2000, 3000, 6000 feet per minute for climb or descent. 200 knots, the airspeed and the altitude selected from the autopilot, also the flight director, the crossbars. So you can see the pitch ladder in degrees. So we have 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down when we fly, the pitch altitude of the aircraft. So this is the primary flight display. Also the flight mode demonstrator, you see the autopilot modes and the auto throttle when we arm them. So you can see also the bank roll. Here is the banks roll of the aircraft when we make turns. So you can see like 5 to 10, 20, 30, 45, 60 degrees of bank rolls like this. Also the wings level over here of the aircraft. So we have the barometric pressure over here set 29.92 inches of mercury. We have to use this barometric pressure for the altitude display, that is the altitude above the sea level, or the elevation of the airport we are located. The runways and the taxiways are 1,400 feet above the sea level, as you can see. So we have the FS panel here, the electronic flight instrument panel. We can set the barometric pressure over here, that is displayed in the primary flight display. We can change that depending on what the air traffic control will give us. We can increase or decrease the barometric pressure. So right now it's 29.92 inches of mercury, or 1013 hectopascals. When we fly above 18,000 feet in flight, we have to set 29.92 standard. Minimums, baro plan, menu, range over here with the radar, traffic and terrain on the display. So we have accept, cancel, reject, some warnings, systems, CDU, info, checklist, communications. This is for the displays. Also here the engines and the map, the navigation display. Also the autopilot, here you can see the autopilot guidance. So we have 10,360 degrees heading and the vertical rate of climb descent, the auto throttle left and right, the flight director, autopilot engage and disengage switch. So you'll see later before we go into flight how we're gonna use them. We have also the HSI here. You can see the map, the terrain, red, green, yellow, amber color. The terrain elevation is displayed 4,500. So you can see at 80 nautical miles distance. At 60 nautical miles in front of us is EDTL airport. Is the Düsseldorf in Germany. So it's 60 nautical miles. We are here in Zurich. So it's 60 nautical miles in front of us in this direction. We fly straight. We can see that from the GPS and the map. Also the magnetic north pole, geographic north pole, magnetic variation. So you can see Lszh airport over here. Zurich. You will see later the runways. Also the altitude we have selected from the autopilot. If we look further away, you will see more airports here. So here you can see more of Germany, France over here, and Switzerland down here. The airports that we have at 160 nautical miles now, the range. You can see range 160. We can decrease again, we'll see closer. Also the mountains in front of us when we fly. So at 10 nautical miles you can see we have some bumps, some mountains in front of us. So this is the aircraft that is 1,400 feet right now above the sea level. You can see the mountains in front of us. Also the altitude we have selected to fly. So you can see also the distance, 5 nautical miles, 10 nautical miles, 2.5, 125 nautical miles. If we look further away, 20 nautical miles, we will see further more terrain. This is the terrain map mode in all airline aircraft, airplanes. Also, if we look up closer, we'll see more of the terrain. We'll see also the airports later when we fly. So we're gonna leave that now. I will talk to you about the flight controls of the aircraft. I will show you now how we're gonna use also the horizontal tail trim stabilizer. We can trim the horizontal tail of the airplanes when we fly the horizontal stabilizer either or the elevator. So here we have an elevator trim switch in the Boeing 787 in the control yoke, in the control wheel of the yoke. Also we have an alternate channel, a secondary switch that can be used as an alternate switch over here. So we have also we have the auto trim system. We have the automatic trim. So this is a fly-by-wire aircraft. You can see the flight control computers here that we have. So this is a fly-by-wire aircraft. It has the flight control computers also to control the flight control surfaces when we fly, like in the Airbus aircraft. The Boeing also now has a fly-by-wire system. Also it has the auto trim function, like all airliners airplanes. So we can either trim manually or we can allow the aircraft to trim itself automatically. Also when we use the autopilot flight director system panel with the auto throttle, the aircraft also use the automatic trim. So also now the flight control computers, we have the normal, the alternate, the direct and the mechanical backup modes of the flight control computers that control the aircraft flight path in flight, and the flight controls also take commands from the autopilot flight director system panel. So we have a failure of some system like the hydraulics from an engine failure. For instance, we're gonna have some failure of the elevator, maybe horizontal trim stabilizer control, so we have to disconnect the auto trim. So I will show you now how to do it over here in the Boeing 787. As you can see, I have the sizing, I have the trim switch over here, also here. This is the manual trim switch. So this is the flight control computers over here, primary flight control computers. We have a failure of the hydraulics over here. You can see the left and the right engine driving, primary D1 or the electric C1, C2. We can have the flight control computers are going to be degraded from normal to alternate or direct mode. We're going to be having to disconnect the autopilot flight director system panel, fly manually also. So we can see also an aircraft that is coming for landing, a Boeing 737-800 over here. Very beautiful, as you can see. Let's start down over here. So we have to come down here. We have failure, the grade of the hydraulics system and the flight control computers. You come down here. You see this red guard switch if you are in a Boeing aircraft. This is for all Boeing 737, 747, 757, 767, Boeing 777 and Boeing 787. You open this red guarded switch, so you can see stabilizer left and right from normal to cut off over here. You can read cut off. So you open from normal over here, either the left or the right horizontal stabilizer switch. Then you're gonna lose the automatic trimming. Maybe for both, if you disconnect both, you will have no autopilot. You have to fly manually. Also, you have to use the manual trim switch for the horizontal tail over here. So you use the manual anyway over here when you fly manually. So you can see this way you trim the elevator up. You pitch the nose of the aircraft up as you fly. Some aircraft have the trim wheel over here, like the Airbus A320 has a trim wheel, and the Boeing 737 also a trim wheel. The Boeing 787 has a switch like the Embraer aircraft. So you trim either up or down like this. or the CRJ aircraft using these suites. So you can see elevator trim, left click down, right click up, very easy. This way it's you can see here the elevator. So we climb it and we descend using the side stick or the yoke. The elevator also we have the trim for the elevator or the whole stabilizer of the aircraft. Some aircraft have the whole stabilizer trim. So it's also you can see we have the parking brakes over here on and off. Also here next to that, not confused with the stabilizer trim, is the control for the fuel flow to the left and the right engine. You can see also the left and the right thrust levers. So if we disconnect the auto trim, we use the manual trim switch over here. You can see manual over here. So we have the elevator trim switch. So this way you trim, you can see elevator trim, left click down, right click up. So this way you pitch the nose up, you trim the elevator up. This way you pitch the nose down as you fly. You have this aerodynamic effect, and you trim the elevator down. So this way you pitch the nose up when you trim the elevator up. You got this aerodynamic effect, very easy. Also to use over here the control wheel for flying the aircraft, making turns left and right. Also climb and descent the control column like this. Also the rudder pedals. Also you have the flaps limit over here, the autopilot disengage over here, the head-up declutter over here. So hope you can read. We have the elevator trim switch. Yes, now we can read this better. So this way you trim the elevator up, this way you trim the elevator down, very easy. So I will show you the rest of the system, so you can see how many degrees you pitch over here just above the pressurization of the aircraft. You see you have the flaps position now is fully extended 30 degrees. The stabilizer trim right now is 4.5 degrees. You can see it's inside the green button is set for takeoff, within the limits for the takeoff of the aircraft. The rudder trim right now is 0 degrees. We don't need the rudder trim, I don't use it too often. So we have also the gross weight for takeoff over here, and the total fuel board, the fuel temperature, the saturated air temperature, total air temperature over here. So this is how to use the stabilizer trim, very easy. Also the alternate and the cutoff switch if you need it. Also you can see here we have, as I told you, the thrust levers, fuel control left and right engine, fire extinguishers left and right engine, the transporter, the rudder trim, radio communication panel. You can tune the communications, high frequency, very high frequency, satellite. Over here change frequencies. So we have also I'm gonna show you now the outside view, how to use the flight controls of the aircraft. So I'm gonna show you now the outside view of the aircraft of the Boeing 787. I will explain you some principles we need to know for the air transport pilot license, the DPL theory, and the commercial pilot license, the CPL theory. We need to know aerodynamics, flight dynamics for the airplane, the Newton's physics and the Bernoulli theory of fluids, and some other aerospace engineering principles. So I will show you the outside view of the aircraft, and I will explain you the things we need to know, the theory of the air transport pilot license. So we go on the outside. Also you will see the flight controls of the airplane. So for this airliner airplane, you can see the surface area of the wings called the weight of the aircraft when we fly. So the weight of the aircraft when it's flying from the aerodynamic lift of the wings, from the airflow. We have an airflow that has higher pressure below the wings because there is lower airspeed below the wings of the airflow. That pressurizes the aircraft weight up into the air. Also there is a lower air pressure above the wings, which sucks the aircraft weight up into the air. So the lift acts over the weight downwards somewhere here where is the engines located, symmetrically with the center of gravity and some other stuff. We need to know the longitudinal axis and the vertical axis, the yaw axis. So we have the lift, maximum lift over here. So we have the thrust from the engines. The lift acts overcomes the weight, and the thrust from the engines, that engines overcomes the drag from the skin friction. So we have the engines here. So you can see the core of the engines is the high pressure compressor and turbine over here, and the high speed Saturn shaft, the high speed spool. Also we have the combustion jabber in the back section of the high pressure compressor turbine. Also the front spool is connected with the low speed Saturn shaft, the low pressure compressor and turbine in the front, and also the front fan that has a lot of bypass. Here you can see this around the core section is the bypass from the front fan. As you can see, that produce also some thrust. So we have also the fuel flows coming down from the suspension of the engine. Over here you can see we have the fuel lines to eject fuel from the low high pressure fuel valves open. We have also the fuel booster pumps over here, and the fuel tank left and right wing fuel tank, and the center tank over here. So we have also the wing and engine anti-ice hot air over here from the engines, also coming back from inside the aircraft from the manifold. We have also the mineral aerodynamic chord position, the Mach, which is 23% of the mineral aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. Is also the position where the center of pressure moving back and forth when we fly. Also the stall will begin over here in the top surface of the wings. The airflow becomes detached as we fly, and the wings are stalled. So we need to monitor inside the airplane. Over here you can see the primary flight display. Displays the airspeed indicated over here. Just below the airspeed indicated when we fly, we have a red and yellow or amber indication. We have the stall speed. We need to avoid stalling the airplane. So we press the side stick down when we see the stall is coming in, or the yoke of the Boeing aircraft, and also apply more thrust afterwards when you have decreased your angle of attack. You can monitor the angle of attack of the aircraft or see outside. So this is the stall avoidance. So we have also where the mineral dynamic chord is the center of gravity over here. It's the yawing axis of the airplanes. So the yawing axis is the rudder in an aircraft to make left and right turns using the rudder pedals. And also in the ground, when you take off or land, or you are taxiing, you can use also the nose wheel together with the rudder. In the rudder pedal system, it's automatic. You don't need to do a changeover. It's done automatic. So you can see here inside the airplane, we have the rudder pedals of the Boeing aircraft, similar to the Airbus or the Embraer or the CRJ aircraft. So we can control left and right turns, the rudder, the vertical tail rudder when we fly, or the rudder and the nose wheel when we are take off in the runway or land. Also the nose wheel steering in the ground, so we can control the nose wheel only when we are in the ground, like in the taxi. So you see the rudder pedals act to control the rudder function left and right, the yawing axis. Also we have together from 0 knots the nose wheel steering of the front nose wheel. We can deflect the nose wheel automatically from the computer from 0 to 76 degrees with the left and right deflection. As we accelerate for takeoff, also as we accelerate for takeoff, we increase the airspeed above 45 knots. The rudder becomes aerodynamically effective a lot more. So the computer will decrease the deflection above 45 knots or 72 kilometers an hour. 45 knots from 76 degrees down to 7.6 degrees deflection either left and right for the forward nose will like in takeoff or after landing. So as we accelerate even further, you don't need to do nothing, only press the rudder pedals in takeoff or in landing. As we increase the airspeed above 80 knots or 144 kilometers an hour, the rudder only becomes aerodynamically effective and is used for steering. Then forward nose is gonna be locked into zero position or very small deflection like half or 1 degree. So we're gonna be having only the rudder aerodynamically effective to control the aircraft above 144 or 80 nautical miles per hour is locked to zero. Deflection, then as we accelerate for takeoff, 250 kilometers an hour or 140 knots, we have only the rudder again. Then as we land, come down for landing. In the air we have only the rudder. Also when we come for landing after touchdown, as we slow down, the forward nose will also come in from the computer automatically. Below 80 knots, it starts moving. So we use this system. Also you can see, so this is the rudder pedal system and the tiller and the toe brakes system. I have it here in the side stick. Also we have one more axis from wingtip to wingtip, is the pitch axis. In the Airbus you use the elevator and the Boeing also. In all aircraft you use the elevator. In the Airbus you have the side stick to move the elevator for climb descent like this. So you control, you take the weight up and you climb from the elevator, from the tail of the aircraft. You take the weight down, you descend. Very easy to remember. We have another aircraft is coming for landing. Boeing 737 again, 800. So you have the elevator for climb and for descent using the side stick in the Airbus. In the Boeing you control the elevator using the control column of the yoke of the Boeing 787. So it's the same function like the side stick deflection, the same. As you can see, like the yoke, no difference. You take the weight down, up and you climb, you take the weight down, you descend. You need to add or decrease the thrust also at the same time. So now I'll show you one more axis. This is the longitudinal from nose out to tail in the Airbus. You use the side stick, left and right turns. You control the ailerons and the spoilers of the Airbus for left and right turns. In the Boeing you have the aileron, spoilers and also the flapper on here. One more control surface. You make aerodynamic lift difference between the left and right wing like this to make left and right bungle turns in the air. Very easy. The roll axis of the airplane. So you have all flight controls together, coordinated flight, rudder, elevator, aileron, spoilers. Also you can see the flaps are extended over here, the speed brakes also, the flight spoilers and the flaps with the slots extended. We need the flaps also to increase the lift. So we have over here, we have the control wheel for making left and right turns in the Boeing aircraft. We have the side stick in the Airbus. So very easy to remember. Also you can see the Airbus, I told you, has also the Boeing 787 and Boeing 777. You have the flight control computers. These fly-by-wire aircraft. When you fly the aircraft, flight controls are controlled in order to make the aircraft maintain some Z, where Z is the acceleration of the air gravity limit. So when you're flying straight and level with the Airbus maintains also the Boeing 1Z corrected. Also when you make turns, like you want to make left and right turns or climb descend the Airbus, you make G acceleration commands from the side stick into the flight control computers mode. So you can see in the Airbus you make left and right turns. You have maximum 67 degrees left and right or 2.8 Z. When you release, the side stick is maintained at 33 degrees maximum, and you have to use the side stick again to turn back to level flight. Also, when you climb the Airbus, you have a 30 degrees maximum or 1.5 G of climb rate, and a minus 15 degrees or minus half G for descent. Boeing has similar features. We have also the alpha protection, the 1G stall, anti-stall system for the 1G angle of attack when the aircraft reaches the angle of stall, which applies full takeoff thrust in the Airbus and locks the angle of attack. So we have other features, other speed protections. So I will show you one more view of the flight controls of the Boeing 787 right now, and then I will make the flight control computers, the flight management computer set up for this flight. So you will see now one more view of the flight controls of the Boeing 787 over here, very nice view. I hope you're gonna like it. Also the computer that I use. So you can see here we have one more view. We can climb, you can descend, we can make turns to the right, turns to the left with the airplane in the air. Very easy. Also you can see the side stick that is identical to the Airbus. So the side stick deflection is proportional to the yoke deflection. Both sides in the Boeing aircraft are interconnected of the flight controls of the yoke and the control wheel system. You need to use an override force in the Boeing airplane. In the Airbus you have the side stick priority or dual input, also the autopilot is engaged, the push to talk also over here in front. So hope you like the Airbus and the Boeing flight control system. So very easy to use. Also you can see we have the thrust control over here. You can use the thrust levers like this to increase and decrease the engine's thrust. So you can see very easy. How many degrees you use the thrust levers, you have the thrust commanded displayed from the engines over here. So hope you like the side stick of the Boeing 787. So we climb, we descend, we make turns to the right, turns to the left. Also the thrust levers over here, thrust control, increase and decrease over here. So climb, descend, make turns to the right, make turns to the left. So we have the outside view of the flight controls using this side stick view. So you climb, you descend, make turns rather, and ailerons and spoilers like this, very easy. Climb and descent, also ailerons and spoilers. So this is enough for the flight controls lesson right now. We're going for the flight management computer. Over here, set up the flight management computer. We have not much time for this flight. So now I'm gonna set the flight management computer, enter all the data. It's gonna be used also from the autopilot flight director system panel when we fly the aircraft with the VNAV mode. So you can see I have the mouse pad here to control the keyboard, also the screen of the flight management computer. So over here the keyboard, the mouse pad, we can select left and right the screen for display, keyboard and the display of the CDU. So we have the index here, DDT position, performance, takeoff, approach, annunciate status, navigation data, flight plans. So we go here for this view. Over here, better view of the aircraft. So you can see the control quadrant again. So the identity of the airplane, Boeing 787, GNX engines. The position, Lszh Airport, Zurich International Airport in Switzerland. The coordinates of the airplane, so we can align the IRS if we need, the magnetic and the geographic North Pole, performance, takeoff, 0 fuel weight plus fuel on board, gross weight for takeoff. The reserve fuel over here, 5%. Cruising altitude 25,300 feet, coast index in flight, minus also fuel freezing temperature minus 37 degrees, and the cruising center of gravity 28%. So we're gonna set the route from this airport, Lszh in Switzerland, back to Lszh in Switzerland, copy paste. So clear. And we need to set up the departures and the arrivals. We use departure runway 14. So departures and arrivals index, we use departure runway 10, 14, 16, runway 16, runway 28, runway 32, runway 14. We select runway 14, and the Zui to Alpha is the seats, the southern instrument departure waypoints and fixes, and horizontal vertical navigation fix out generally conflict. We go in the arrival to complete the flight plan. So we have approaches, runway 16, runway 28, runway 34, runway 14, ILS 14, bomb 16. Also ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14, trans Amity and trans Negria 1 Alpha over here. So we have the legs over here. The route is displayed with blue, is not yet activated. So we have the first waypoint, the autopilot we follow later in flight. The flight plan, Zui, climb to Zui, make left turn over here, climb to the Nigria, then Amiki, descend, approach and landing through the Zurich 701. So we set the reserve fuel on board and gross weight for takeoff, the cruising altitude, and we activate the flight plan. So we press this green switch, the execute, that is displayed now. We will activate the route, the flight plan of the aircraft. So it's displayed with purple over here. It's activated. So you can see first waypoint, Zui 6 nautical miles, 301 knots, 6000 Alpha, Nigria 26 nautical miles, 071, heading 301 knots, airspeed flight level 22,200 feet, Mativ 12 nautical miles from Nigria, Amiki 6 nautical miles, Zui 9 nautical miles, back to the airport, Zurich 701, 6 nautical miles, 108 knots, 6000 Alpha. Then make a left turn here at Osnem for alignment with the airport runway in the ILS, 174,000, runway 14, 141,430 feet. So we have flaps 15 degrees, center of gravity 23%, 4.35 degrees for takeoff, and the takeoff speed V1, V0, V2 for this gross weight and this runway. So we have also departure, arrival, alternate, VNAV, progress, FMC communication, hold, legs, set a fix. We can hold over a waypoint in flight, and also navigation radio, Q9 less localizer, and a VOR and ADF. So we go back in the virtual cockpit. We're gonna use the displays here now a bit better. You can see the flight one we have created. You can see the purple line. Also you can see the runway, the taxiway we are located right now, the other taxiway, the elevation of the terrain. So we can see the taxiway here that we are on, and the runway. The aircraft is over this taxiway, and also the runway beside us we're gonna use for takeoff for landing. The other runway, the terrain. We have the display from the terrain map and the weather radar. Also the flight plan. So we can look also the center display, 360 degrees further away. Also this plan display over here very quickly. So you can see map centering over here as displayed cursor. the elevation of the terrain when we fly, warning, and also the aircraft symbol over here, the runway, how close we are to the runway. So we look a little bit further. We're gonna see the overhead panel. We're gonna set the engines start now. We need the APU, the auxiliary power unit is gonna give us pressurizer and electric current. Also the batteries, we have the ADG from the engines when they work, 100 to 200 volts, 400 Hz frequency, 100,000 kilovolts. Primary flight control computers in the auto position, air data computer. Over here, flight control services. Over here, battery, the towing power, FD door, passenger oxygen. Over here, also we have the window sheet, rammer turbine backup hydraulics, and when we turn off the hydraulic left and right engine driving, we see the fold display. We turn back on, then to the auto position, primary demand. Also we have the wing and engine device over here on our auto position. The cabin pressurization here, we have the bleeder also. So in the automatic we need nothing to do. In the manual we use the outflow valves to depressurize or pressurize the cabin when we climb the ascent, select the landing altitude. So the auto now. Also air conditioning, pressurizer for cabin pressurization, oxygen, hydraulic fluid tanks, pressurization, wing and engine radios. So we have also the recorders over here, the cargo and APU fire. Also we have the engines, electronic engine control for the engines, normal and alternate mode. The control the fatics. We have the start for the engines. This controls the start. We have the fuel jettison. We can dump some fuel in flight, select the arm and select the nozzles and how much fuel to remain to make an emergency landing. We have also the left and the right wing fuel tank, center tank, the crossfeed valve. We would turn it on, interfeed either engine with either pump or either tank, and also balance the fuel between the left and the right wing over here. So this is the valves control for the fuel and the fuel booster valve. So we need to now see the last system before make the engine start demonstration. We have the systems display here. You can see hydraulics, the APU is running, the data, oxygen, quality and liquid cooling, the electric, left and right IZ, 130 to 200 volts, 400 Hz frequency, 120,000 kilovolts, the APU generator, the load set, the main battery, and the APU battery charge or discharge, volts and amperage, the hydraulics, with hydraulic fluid goes, which systems use hydraulics, left and right engine driving, primary demand, electric C1 and C2, fire isolation valves, shut-off valve, also the quantity of hydraulic fluid and the pressure, 5,100 psi. So we have the fuel on board the aircraft. You can see left and right wing, fuel tank, center tank, 11,000, 11,000 and 11,000, total 33,000 over here. Also you can see the minimum fuel temperature when we fly the aircraft at higher altitudes. The fuel will freeze in flight. So you can see minimum fuel temperature over here, minus 37 degrees, and the fuel temperature minus 6. So the recirculation of the fuel is done automatically from the fatics. We don't need to do nothing. We have the transfer of fuel from the left and right wing fuel tank and the center tank into the engine components to heat up the fuel in flight. Also the lubricant and the oil, which turns back to the fuel tanks. This is done automatic from the fatics. Also we have the low high pressure right now, fuel valve open and feed from the center of the left and right wing. The crossfeed valve is off, but we turn it on. We can feed either engine with either pump or either tank. The APU is fed from the left wing using the DC motor. We have pressurizer for oxygen and cabin pressurization, hydraulic fluid tanks. Doors are closed, the cabin can be pressurized. The gear, temperature of the brakes and pressure of the tires, flight controls. You can see the flight controls left and right turns, also the rudder, climb, descent, the elevator and the rudder, left and right turns. Also you can see this is the last thing we need to do before going into flight. Check the flight controls over here. Also FS display, status, maintenance, circuit breakers, maintenance. We have the checklist. So we have the normal menu over here. So So we have pre-flight, before takeoff, after takeoff, descent approach, and landing over here. So we have communications, also navigation display. Back to the engine start. So we turn off both engines. We use some lights over here, landing and nozzle steering lights. So we turn off both engines here. Fuel control to the off position. So you see the messages, the pumps are off, the engines are going off right now. So we need to restart them. Close the engines. So you can see the Boeing 787. The hydraulics also going off. So we need to restart over here. You can see the auto start, both start switches. We can see the reconfiguration of the switches with yellow light in the overhead. So we have only pressurizer right now into the end two stage of the engine. We have no fuel, so above 20%. You can hear we have only pressurizer, no fuel flow yet. We let both fuel control to the on position like this. So we're gonna have the auto start coming in. Turn on the auto start. So we're gonna be having both pressurizer from the APU now and fuel flow. So the stages of the engines are coming up, the N1 and 2, everything controlled by the FAREX. So the auto start 47. You can see the yellow messages are going off. At 62% we have both engines running. So we're gonna go for takeoff, speed brakes, arm flaps for takeoff over here. Also the autopilot, one last thing. Before going into flight, you can see we have the LNAV and the VNAV now function, also the flight director. If we turn the flight director off, the modes are going off. So we said LNAV, auto throttle left and right, autopilot disengage like this. The airspeed we're gonna set 253, bank angle limit and heading select in flight. Also vertical speed zeros, descent over here, and climb, which is set plus 3,500 feet. We have minus when we descend, plus when we climb. Also the altitude set thousands over here, and hundreds. So now we have the autopilot panel set. We can go for takeoff. So parking brakes off, advance the thrust levers. We take out the clearance from the air traffic control, taxi to the runway. For takeoff we have no other aircraft coming in. So we use idle power for the taxi. Also we use the killer. There is no other aircraft. We taxi for takeoff over here. So we advance over here the thrust levers, also here as you can see, thrust levers to full takeoff power, and also we can use the side stick down until 80 knots, so the yoke, push the side stick down, halfway down, so 80 knots, release the side stick, 100, 120, 30, V1, V rotate, we pitch up like 9 degrees for rotation, very small pitch attitude for the initial climb, not hit the tail as we take off. So you see how easy it is. You can leave the hands off the side stick There is no problem after a few hundred feet. Only the airplane can do that. I would thought. The hands on the control, no other flying machine. So you can see here, we keep climbing. Also the airspeed may increase. We have also, so here we are 1,600 feet above the ground, 1,800, 900, 2,000 feet above the ground, about 3,600 above the sea. The airspeed 180 knots, the stall speed red and yellow here 120 knots, will decrease the pitch attitude to less than 20 degrees. The wind direction and speed now, also the terrain around you and below you. You can see the trend of the climb over here. As we're climbing, also the terrain. So we look at the terrain below us. You can see the red, the green below is 3,500 feet. The aircraft is 3,700, 800, 4,000 here feet above the ground. You can see the ground with a green line below us as displayed the distance. This green line is the ground below us. We have to climb. We are almost 8,000 feet. You can see the terrain also around from the map. Also again monitored for the stall speed over here. Also the engines indication. So we have a few more minutes. Look further away over here. We see more red, green, yellow. The engines, also the flight one. So we have the outside, the landing gear up. We have positive rate of climb, landing gear up. So we have also depart the runways, the view of the Switzerland, and we need to start the turn now. So we have almost 15 more minutes for this flight, for this video to end, maybe 30. So we keep climbing, as you can see. So we have the beautiful outside view of the Switzerland. Also the night sky, as you can see. Hope you like the aircraft as we fly the Boeing 787. Maybe we're gonna use the autopilot, maybe not. Maybe we not have enough time to use the autopilot in this flight. Maybe we're only gonna fly manually. This is no problem for us. We can fly the jet airplane very easy. Beautiful jet, the most beautiful jet aircraft in the world, Boeing aircraft. So we can climb here, as you can see. Keep climbing. Also make some turn in a couple of minutes. So this is the view over here. The Switzerland, the lakes, the Swiss Alps, the Germany, my homeland in front of you, and the France. So we're going over here. We need to make some small turn with the flight one. Use also some rudder pedal. If we need to make right turn, right rudder pedal, left turn, left rudder pedal. Very easy to remember. Alongside with the control wheel. So you can see we are close. The stall speed, the red and yellow is 120 knots. The first waypoint, the intercept, we're gonna have to fly through the zoo right now as we're climbing. You can see also the indications from the head-up display over here, the engines indication, the flight management computer also, and the autopilot set already. Also the flight plan in this side. You can see more of the flight plan. On the other side, I have broader view. So small correction here for alignment with the flight plan. So we make a right turn now to align with the flight plan. You can see we are flying here this area. We have to be aligned with the modes here. Also you can see the Zui is the next waypoint we have to fly through, 2.2 nautical miles, a bit to the left. So we are here overflying the France in this side, Germany, my homeland, Bayern Munich, the lakes and the Swiss Alps. So we're gonna make the turn now, very fast turn for the next waypoint. Also we're gonna use we're gonna cancel this army key over here, execute. We're gonna fly faster over here, over this waypoint. So we commence manual flight control stern like this, flying manually. As you can see, almost 21,000 feet. We need to level off now. Also use less flaps over here as we turn. Increase the airspeed, so we flying over. We have a few more minutes. As you can see, overflying Germany over here, flying manually. Boeing 787. Germany, France over here. Also the view of the Boeing 787. Hope you like it. So we're going back for the flight plan over here. We need to align ourselves and accelerate the aircraft. You can fly also. Use the autopilot mode if we need to fly the aircraft with the autopilot right now. So connect the auto throttle, autopilot on. So now we're flying straight the flight plan. Also we can decrease the angle of climb of the aircraft, and also increase the airspeed like this. So here we are, we're flying over the France, the Swiss Alps, very beautiful view. As you can see, most beautiful view over here. The galactic view outside the airplane. So we have the Swiss Alps over here, the lakes and the Germany, the Bayern Munich behind us, the France. On this side we're going back to the airport, as you can see, with the Boeing 787. So we need to start the descent now. So in order to go back to the airport, we have the autopilot engaged right now, as you can see. So we need to decrease the altitude. Also the vertical rate. Also the airspeed, accelerate. So here we go for approach. Also aligning with the flight plan. As you can see, we have the airport over here. So keep descending. Speed brakes also applied. We can reconnect the autopilot whenever we need. Like this, you can see the autopilot now is engaged. We have the AP on here in the display. So we keep flying. Also descent rate increase. We need to follow the waypoints. We take back manual control whenever needed. So increase the rate of descent. Also the view inside the cockpit. That's before going into landing. So we are 15,000 feet. We need to start the turn now, as you can see. Keep descending and start the turn over here as we are descending. So here's the manual turn. So you use also the rudder pedal left to align, to make the turn a bit faster. Also more idle thrust. So 2 more minutes for approach and landing. To align now with the runway heading over here. So here's the runway in front of us. Keep descending. Use a little bit side wind, left rudder and right rudder over here. Also landing gear down. And also flaps. We're gonna use some flaps for approach and landing, as you can see. Also the landing view of the airplane, the Boeing 787. So we have a few more, 1 more minute for approach and landing. Very easy. For us, we're gonna make a manual approach. We have some side wing over here, some wing gas. Use a little bit more thrust. We need to use all flight controls when we have side wing to align with the runway. So you can see also the Lszh localizer, the information that we need to follow. So we need 2 dots down over here. more idle thrust. Align again with the flight controls. So we are aligned with the runway. Increase a little bit the rate of descent, and we need to level off for the flare. So the flare is here. We flare the airplane. As you can see, beautiful flare, beautiful touchdown. Very professional. Align with the center line also. Parking brakes and idle thrust and thrust reverse over here. So we align with the center line. Some wind, side wind, and thrust reverse. As you can see, thrust reverse. Slow down the